like to introduce Madhuresh Nagshain to my students and my fellow friends, teachers. Madhuresh is Indian-born American. He is presently in USA and he is born at a village of Madhubani. And after that, he graduated from BIT Sindri in electronics and communication. He was, in fact, topper of that branch, 1975 branch. And then he did MTech from Indian Institute of Technology, Kanpur, in computer science. And this is his credentials. And about his summary of experience, I would like to say he's man of versatile experience, not in the field of computer. He has developed many electronic chips, and it is already patented by US. 5 patent he has got, and he is presently doing his own venture as a director with semiconductor industry. A strong professional skill he has acquired in device drivers, cloud computing, RAID, firmware, and embedded system. And he was with Silicon Image for 13 years, 10 months in USA. And he is director of D company from June 12 till date. And he has acquired in this field as a professional of 8 years, 5 months experience. He has also developed embedded software development for HDMI and MHL connectivity solution using SIMG devices. And he is consultant of Cisco. He was consultant of Cisco from 2000 to 2007. And he was also engineering manager from August 99 to September 2005 with Adaptec Inc. And he has managed a large group of engineers in 3 locations worldwide for device driver development across Windows, Linux, and NetWare. Products were as noted as SC, SI, RAID, SATA, SAS, etc. This is about Madhuresh, and he is a man of very human feeling. 3 years back, he has also gifted 1 laptop to our students. Now he is in final year, and in this way, he wants to help others, all the young budding engineers, and it is his missions to nurture the career of young boy from Bihar particularly to excel as a successful engineer of the future. And in this way, he is very generous to inculcate values as well as skills and knowledge to young professionals. And he is very motivated, a spiritual person, and he wants to help others. Bright boy from Bihar, particularly BC Bhagalpur, BIT Sindri, MIT Muzaffarpur, and another new colleges of Bihar. And he is willing to deliver lecture, but anyhow, I was not able to manage his time. It is all about the Madhuresh, and I think Madhuresh will himself introduce better than me about his field of interest. And today, discourse will be focused on innovations and artificial.
Nirmal, you are muted. Sentu or Nirmal, can you unmute yourself? Okay. Can you guys hear me? Pradhan, can you hear me?
Hello, I hear you,
You can hear me?
Tiwari.
Okay. Oh, hi, Tiwari. Thanks
I,
for joining in. Yeah, and thanks for being. So let me give a few minutes to Nirmal, if he can join in.
Now we
I
are
think.
connected again. So
Oh, there you go. Yeah.
I am inviting Madhuresh to deliver his lectures on innovations and artificial intelligence. And I request all my friends and students to welcome him by giving a big applause clapping.
Thank you, Professor Nirmal. It's been great to be associated with you and with Bhagalpur College of Engineering. And I believe for this presentation, there are a couple of other colleges here, right? One is a college in Baka, the Bihar College of Engineering, right? And the other is the Agriculture University. Is that right? Okay. So, yeah, first of all, extremely sorry. Somehow the time zones are different. For me, it is night. It's 10:30, let's say 10 o'clock, 10:03 p.m. in the night. And I was of the understanding that the meeting, this presentation will start at 10:30 India time, which is 10 p.m. So I was preparing for 10 p.m. and uh, I need to keep the sound and everything quality better. So I was working on that. I didn't realize that Professor Nirmal was waiting and everybody here was waiting. So big apology to everybody. And normally that should not happen. It's absolutely in my dictionary, it is kind of criminal to do that. So sorry again. The what he described as course, he said he said all kind words. Thank you so much, Professor Nirmal. Yes, a couple of years ago, which is to be precise, I think 2018, I did take U.S. citizenship. So you can call me as American, American who was born in India or whatever. But the heart stays in India. Right? Heart stays in Bihar actually, and it's very difficult to forget. Even if, let's say, half of my life is in India and half here, but the time in Bihar particularly in fact it's very interesting because even in the childhood I got into hostels. I stayed in UP mostly, used to come back to Patna or Ranchi or wherever my parents were for short while, so that's why you do not feel the Bihari accent per se. Okay. But everybody in my home, they all always spoke Bihari, and this January I was in India, so and Bihar in Patna, so naturally it's all there. It's all, I'm still a Bihari. And I do joke with a lot of people who meet me who are from southern areas because my name somehow sounds like South Indian. So with all these things, the basic thing is I'm a human, period. Okay. I'm a human who can work with anybody anywhere on the planet. It doesn't matter where I am. As long as things are interesting, people are good, which is what I feel every day is good. So I just like to engage. So if somebody needs something, I would like to yeah, so Rajiv is also my batchmate, and he's saying Dil se Bihari. Yeah, exactly. I mean, given a chance, actually, even if I stayed so long here, it was extremely difficult for me to switch to American citizenship because it looked like, oh, okay, if I have to go to India now, I have to take a visa for India, which is very awkward. So yeah, Dil se Bihari, you can say that. Okay, so my purpose is, of course, not talk about me as much, though you wanted some brief and you understood what I am, where am I from. I had the initial, what do you call, dream when I was in probably in St. Xavier's Nachi, that I wanted to get to a point where I can get a Nobel Prize. Okay, so I was not at all interested in engineering. But then some sequence of events happened and I landed up going for the test, got it, and joined BIT Sindri. And then onwards, when I look back, of course, my father pushed me for doing that. I think I made the right decision because something that came with engineering was innovation. The curiosity that I have, which I still, I mean, even at this age, actually, I'm always curious. I'm always looking for something new. It could be any field, whether it is medical or engineering or anything. I deep dive. I try to get to understand what's going on there. In terms of real achievements, there you get a thrill. You achieve, you make a product. A lot of people start using it, and when people come back and say, I use this thing, and I say, okay, good. Inside that is me. Okay, so if you are using an Android phone, for example, I'm there inside. Every single Android phone uses a chip that was designed by me and my team. Okay, you heard HDMI from his statement, and HDMI stands for High Definition Multimedia Interface. But essentially, what has happened now is that billions of devices, they are all enabled with HDMI. Your laptop has an HDMI, your TVs have HDMI, your cell phones have a way of connecting to HDMI, projectors have HDMI. So it's not in like a crore or lakh, it's billions of devices. And that comes with a lot of challenge, because the moment we do something new, now we have to make it work with the previous billion. Okay. So it's extremely challenging field to make sure that the whole world or ecosystem of HDMI works smoothly, right? So from the point where I got curious, started doing something, make the product, got very interested, enjoyed it. That's my return. And now the point where we are trying to make bigger things happen, worldwide effects. Every single Samsung TV that you see, we are inside that. Every single LG TV, we are inside that. So it feels very good that you created something and everybody is using it. That's the reward you get. And that's the good part about innovation. When you make something and if everybody likes it, you will get so much satisfaction that money doesn't matter. Money will automatically flow. If you did do that, think of it, how many devices HDMI has been sold, and we make kind of a 4 or 5 cents every device as a license and patent holder. That itself becomes huge amount of dollars. Money will automatically flow. What you need to do is keep your child feeling alive. I mean, I'm 61-year-old, but I call it myself flip it, 16-year-old. Keep it alive. Keep on looking for things which are interesting. Be curious. So that's the kind of PowerPoint that I made. To be very honest, I didn't spend or I didn't do enough that I should have because of other engagements I have right now around. But all right, so this slide basically says that, I'm making a claim that last 200 years have been very rapid progress that everybody knows. And even though scientists have been responsible for inventing lots of physics and chemistry and biology topics, essentially a train or a car or airplane, they've been all built by a bunch of engineers, lots of engineers. So engineers are the ones who have created, and they have actually changed the whole world, made it extremely fast. So if you look at the history of world, you will see that there's very little development from year zero to, or let's say 81 to almost like 80, 1200 or 1500. And then suddenly a lot of countries in Europe and other places started doing new things after 1500. Because that's the time education took front role and people started building things and researching stuff. Like they started researching human body itself, human mind, and so on. So it started in 1500, but it is more oriented in philosophy and science and stuff. Around 1700, suddenly from 1700 to 1800, what happened is the industrialization and building trains and building engines, those things started, where the engineers came into play. So basically, in my claim, the world has been changed rapidly in last 200 compared to 2000 years by engineers. Okay. All right. The next, as an engineer, you are the practical scientist who applies things, yeah, applies learnings of life into real world stuff. So basically your job is whatever scientists are finding, use those, whatever you have learned, use those, and then create something new. Okay. And at each step, you'll be offered an opportunity to apply your knowledge, your creativity, and your intelligence to make the world a little bit better. So even if you do one little change, like you had a car which ran for 30 miles per hour, and now you make a car which runs 40 miles per hour at the upper limit, or 60, or now you can do something like 300 kilometers per hour, which is 160 miles per hour. You are actually innovating and making it better. And that's exactly what engineers are doing. Engineers are applying all their creativity, finding one innovation at a time, making a new thing which makes the world better. So when I talked about HDMI, for example, it wasn't something remarkably new because the TV was there before also. The HDMI came in 2000. TV is a black and white, then became color, and they were always carrying multiple wires for speaker and sound, I mean, audio, video, and so on. What HDMI did is it actually increased the screen quality remarkably, high density, and one innovation, and that made a whole lot of difference to the rest of the world. Now, if you go and look back the black and white TVs or TVs which are old style, it doesn't look good at all. In fact, you not even go to that use those. So even a single innovation makes a lot of difference to the world. Okay. Okay, so what are the ingredients for innovation? These are very common sense stuff I'm going over. Knowledge, of course, if you build more knowledge, it'll be good. And I will actually touch upon this that it's really not necessary to know everything. But yes, knowledge or education helps you. Curiosity, this is my favorite thing. If you stay curious, you will enjoy what you're doing and you will create more innovative stuff. Creativity, of course, is part of the thing because you are creating. So you should be always thinking what to do next, what to make next. Instead of just being passive, just keep on making something new. Then drive to make things happen. Drive is basically, this is not about driving. It is about really pushing things. Like many times you will see, if you go to do something, there are 100 obstacles in your way. So you should have a way of pushing those obstacles away and get over that, and then make the thing work. Like anything you take, there'll be always obstacles. Don't get scared. Just push yourself hard, get across that hurdle, and then make a new thing. Problem solving. So, and problem solving is interesting because many people get very scared when they look at a problem. But anytime you see a problem, you should actually think there has to be an opportunity. If I solve this problem, I'll make a lot of money, or I'll make something new. Whatever gives you cake. Money everybody enjoys. Who doesn't want that? But at the same time, each problem that you solve is going to help you get a step better in terms of creation. Knowledge. Now, I put some funky stuff here. Do you know the height of Mount Everest? And some of you must be knowing because we used to do something called current events and general knowledge. And you will probably know the number by heart. I don't. I think it's in the ballpark of 29,000 feet, 29,100. I have lived in Himalayas in Nainital for my education, so I know those areas. But okay, so I get a text from somebody called Kumar Rishabh. Can we get this presentation later, please? I'm pretty sure Professor Nimal will post it for later viewing, both the recording as well as the PowerPoint. So there's nothing sacrosanct or copyrighted in here. You'll get to see this later, okay? The second one is, do you know the weight of planet Earth? Now, who the heck knows this? Is something so irrelevant. Why would I know it? And so on. But it's also a part of knowledge, right? Do you know how Earth will end and when? Now, this is prediction. You do not know. It can end tomorrow by if some meteorite comes and hits, or a bad virus just gobbles away the whole planet and then the planet dies, or something extremely unknown because we cannot know everything, right? But we cannot know this. So what you will do is you will predict. And when you predict, you are actually making a guess based upon your knowledge, and you'll say, okay, this is how it happened last time. There was a meteor that struck 40,000 years ago, so this is high time it'll strike, or there'll be an earthquake or something. So you based on your knowledge, you predict. And I'm saying that because this is pretty much where the AI world is headed in future. Okay, so actually, you do not need to know everything, nor is there a way to know everything, because who knows? Is the universe a flat thing, or is it an endless thing, or is there a finite thing? We don't know. We're just making a postulation and guessing it there, and then going to see whether it is really true or not. So, but it's also not very necessary because you are talking about some innovation which makes the life for every human being better. So it's possible to do without knowing everything, and then we have something now. So we work with what we know. Whatever we know, that is our experience, that's our knowledge. Rest of the ingredients are curiosity and all that. If we don't know something, we have a beautiful thing called Google. And interestingly, Google seems to know everything. Okay. So I put a little, beyond that, we make a guess, we extrapolate. But at this point, I actually most likely have an insert of a video here. One innovation seems to know, and this is an innovation, and this innovation uses very cutting edge of artificial intelligence. Okay. That video is what is going to show. Though I say Alexa, that's the name of the person or the name of the voice that is there behind this innovation. But the device is called actually a series of devices done by Amazon, and it's called Dot or Play and those kind of names. But the most of the people would know this by Alexa, and for Google, you know something called Hey Google, and you take your phone and you say Hey Google, and it start talking to you. That's a part of something called conversational artificial intelligence. Okay, so there's a little video. It'll give me a little break to.
Can it hear me right now?
Nope. It only hears you when you use the wake word we chose. Alexa.
Well, what does it do?
Alexa, what do you do?
I can play music, answer questions, get the news on weather, create to-do lists, and much more.
Awesome. Alexa, play rock music.
Rock music.
Alexa, stop.
Wait, I want to try. Alexa, what time is it?
The time is 3:27.
You actually don't have to yell at it, okay? It uses far-field technology, so it can hear you from anywhere in the room.
So it can just hear you anywhere?
Yes. Well, everyone can hear you anyway.
Oh, is that where we're going to put it?
I was thinking of putting it there, but it works anywhere.
Echo is pretty neat because it knows all sorts of things. All you have to do is ask.
Alexa, how tall is Mount Everest?
Mount Everest's height is 29,029 feet, 8,848
How
meters.
can it know so much? It's so small.
It updates using the cloud. That's also how it gets its answers.
Do list.
Paper. Alexa, add wrapping paper to the shopping list.
I've put wrapping paper on your shopping list.
Alexa, how many teaspoons are in a tablespoon?
1 tablespoon equals 3 teaspoons.
Okay. Alexa, set a timer for 8 minutes.
8 minutes starting now.
That's not.
Alexa, give me my flash news briefing.
Here's your flash briefing.
From NPR News in Washington, I'm Lakshmi Singh.
Dad, how do you spell cantaloupe?
Cantaloupe. C-A-N-T. Alexa, how do you spell cantaloupe?
Cantaloupe is spelled C-A-N-T-A-L-O-U-P-E.
Good job.
Alexa, what does the Earth weigh?
Earth's mass is 13 septillion 199 sextillion 999 quintillion 999 quadrillion 999 trillion 999 billion 563,792,384 pounds. 5 septillion 970 sextillion 281,018,368 kilograms.
Alexa, when is the end of the world?
Unless it collides with a very large rock or a future technology goes very wrong indeed. Earth is most likely to be destroyed when the sun swells into a red giant in several billion years' time.
All right, so what you saw is a little older device of Alexa, and I have a newer device out here. Alexa, what time is it? And it will respond you back. You can ask time, you can set up alarm, you can do all kind of things that you want to do. And actually, of course, for Amazon's interest, you can actually ask him to order something, right? Something that that's there on Amazon website, right? Alexa, what time is it?
The time is 10:34 p.m. Enjoy your night.
All right. So what you saw is the newer version of Alexa. Anytime you use the word Alexa, it lightens up. Let me turn the video for that.
I'm not sure.
Okay, Alexa, do you know Professor Nemo?
The name Priscilla means ancient.
Okay, sorry, Professor Nemo. It says like you're very old. Okay, so that is innovative stuff that was created by Amazon, and it is being enhanced as we speak with the help of, am I able to control the screen? No. Okay, now I'm doing the screen. Sorry. So with the help of artificial intelligence. So let me run
You can
this.
control now. Controlling now.
No, now it is my screen. I forgot that I'm doing it. Yeah, I did that. So, all right, we'll jump here. How does Alexa work? So we don't know. We only know that there is a AI inside because it's a proprietary device of Amazon. But you have already heard about a device called Google, Hey Google, and a Google Home. Those things are all on a similar line, and they all operate using conversational AI. Okay. Sorry, my video is off in the process. Next,
Madhuresh,
yeah.
suppose something is not embedded in Alexa, and I am putting question, how Alexa will answer? Here Alexa will tell.
Okay,
This
good question. So Alexa actually is not using only things that it knows. The internet, as you know, is vast and it's always increasing its information based upon, for example, it might be catching our information and saying, okay, there is a presentation going on right now in Bhagalpur. So it keeps on increasing as we speak at a very high speed. And that's not being done by Alexa, that's being done by the internet in general. What Alexa does is it goes to the internet and picks up that information and tries to understand what you said and see if you can find the answer. And that's really a challenging thing. I'll come to that in, I cannot give you full details in a very short presentation, even in a 90 minutes thing. But that is what is happening behind the scenes. There's a huge amount of AI, artificial intelligence that's applied. So it will go and try to figure it out. For example, when I asked my Alexa here that who is Professor Nimble, it doesn't know. So it would have gone and looked around, but she couldn't find the name where it is.
how many times my heart is beating, then whether Alexa is able to answer this or not.
It will not be, because unless you wear a heartbeat monitor and that is fed to the internet, then it can tell you.
Okay.
It doesn't, your heartbeat monitor doesn't have to be connected to Alexa. It could be anywhere on the internet. That information is there. It'll go fetch and then present it to you. There's somebody who raised hand. So there's another person who wants to ask a question. Who's that? Avinash.
Alexa is in making, and it will be improved with time. This is my observation at this point.
Say that again.
It will be able to answer everything in future, and what Alexa is answering, what is embedded in that. If it is embedded that the weight of the earth and height of the Mount Everest like this, then Alexa is able to answer. But in a complex world, there are many questions which is not, which will not be answered by Alexa, as I feel.
So this much I know, that the questions that we just talked about, the weight of planet Earth or anything, it's not embedded inside. There is almost nothing embedded inside. It only has a microphone and a way of taking that data, send it to the internet, and there is a server in the back somewhere on the planet which goes, fetches the information very quickly and sends it back to Alexa, to the speakers, they speak it out. For example, you'd expect that they won't have Hindi music. Alexa, play Hindi music.
Playing Hindi music on Amazon Music.
Okay.
Right?
Go on.
So you will start playing. Alexa, stop. Alexa, stop. Okay, Sitar started. Anyway, so these things are not embedded there. It is actually going to the internet, and whatever is available. Yeah, so somebody is asking me what are the limitations of exam. Rishabh, we actually putting a little email address at the end of this presentation. Put your questions there. Anybody can ask questions there, and I will not be able to answer within minutes. I'll answer within days. Definitely on a weekend, by within the next weekend, you'll get an answer. So these questions are good. I'm not selling Alexa, okay? I'm just telling you that there's a huge amount of artificial intelligence that goes behind it. Okay, so let's keep moving a little bit more here. Sorry, on the screen. Okay, this is a little bit about you and me. When we were born, of course, we knew nothing. For 6 months or 1 year, we had no information about the things around. We were trying to figure it out, who is this person or something which comes to me and gives food and so on. Immediately we fell in love with that person, which is mom or dad, and so on. Until 10 years, it is a continuous cycle of learning new things and building database in your brain. But at the same time, many times you'd have seen some small kids suddenly drawing something very imaginative or painting something, because there's no hurdle to them. Nobody is telling them not to do something new. So everything in their life is new, and they keep creating new. So first 10 years of a human life is full of creativity and imagination. Unfortunately, somewhere around that 10 year, what happens is we start going into practical life, where we need to do our living and earn money and so on, which becomes competitive. Once it becomes competitive, then the only thing that matters for next 10 years is how to get better grades, how to get good marks, get a job, those kind of stuff, right? So the creativity and the innovation that we thought we were starting with, all the imagination, that takes a back seat. Unfortunately, that becomes a habit. Okay. So what I'm trying to warn you with, I mean, of course, getting grades were important, because without that, you probably not get enough money that you can do some more new cool stuff. So that is done fine. Okay. But don't lose that touch of imagination and creativity. That's what I'm trying to say, that now that you're all pretty much set to become an engineer, get to a job, you will get a job. It might take a little bit time to find out the right job and to be paid well and so on. But you need to bring creativity, because as an engineer, that's what you're going to do. You're going to create. At every step, you're going to create. And for that, you need to have that childhood thing back into your fold. Okay. Because basically engineering education does what? It is asking you, forcing you to create new stuff. Okay. So another pause here, and I'll show you something more cool than Alexa. Most likely you guys have heard. It's not a toy. It's actually a car. If you come to my area here, you can see it moving around on the road. The coolest part of this car is, if you look at my mouse, look at this window. It's a 2-seater car. Okay. Right now there's no person inside, and it can go without person also. But what you don't see is there is no steering here. Okay. And it's being driven by a computer which is artificial intelligence enabled, has lots of sensor. You can see at the top of that, you see a police kind of thing, which is basically nothing but a camera, set of cameras, which is multi-directional camera, this thing here. There will be sensors all around the car. Okay. And I mean, I'm privileged that when we drive, we occasionally find either this car or the first experiments that Google did on a car which is very similar to the models that we drive on the road ourselves. And it will come there. Some of those cars have somebody sitting there and there is a steering, but this car, particularly this model that you look at it, there's no steering in this. Okay. And it drives around, it goes around on all kind of roads. It has 2 years ago, it had done about 8 million miles of driving in California. Okay. And very successful design. Isn't that cute? I'll run this video for some time, get some breathing. Go ahead and buckle up. Okay, Annie, here we go. Yeah. All right, Connie, let's go.
There's no steering wheel in the way.
It's really cool. It was like really kind of a space age experience.
Oh, okay. Hooray. We're like yeah.
You said relax. You don't need to do nothing. It knows when it needs to stop. It knows when it needs to go.
It actually rides better than my own car.
Yes, sure.
What she really liked was that it slowed down before it went around a curve and then accelerated in the curve. She's always trying to get me to do it that way.
That's the way I learned in a high school driver's ed.
So if I had a self-driving car, I could spend more time hanging out with my kids or helping them with their homework, even just tending to them.
A lot of those little things for most people have to do with getting from place to place in order to connect and do things, be with people, go places that they need to go and do things. And so there's a big part of my life that's missing, and there's a big part of my life that a self-driving vehicle would bring back to me.
This is the first step for us, and it's really exciting to see the progress we've made. The opportunity for people to just move around and not worry about it, it's going to be incredibly empowering and incredibly powerful for people.
I love this.
Yeah, so this is a video, this is also a little bit older video of when it was called actually a Google self-driving car project. It is now called Waymo, W-A-Y-M-O, the same car, but different name, which is part of the Google corporation itself. But it's a very cool device. I mean, what it did over last, I cannot remember exactly when this project started, something in the tune of 7 to 8 years. But what it did is it forced everybody to rethink their car models. So guys like Toyota and General Motors, they all started paying attention to it, and they started thinking how to put into the car those features in the car. Of course, there's a little problem here. What happens if there's an accident? What happens if it goes and hits a person who is taking a little baby on the worry people who will be responsible, who will pay for it, who will be paid. We need to move it. That's not part of my presentation. Okay, all right. Thanks for muting yourself. So the project is still there. Project is still going on. Google is still trying to make these cars commercial, but there's a major legal aspect to this which is holding it back. In terms of technology, I can tell you that in America, any car that is sold brand new, like a new model that is launched in, has some feature of this kind of a car where it can change the lane automatically, or it can control the brake. If it sees an object in front, it will control its speed down. Or if you suddenly, somebody comes into your lane from nowhere. In fact, there are a lot of people who intentionally do this. They see an automated car and they try to check their behavior, and they put their life on risk because they'll come in front of the car and car will stop, slow down and stop and turn around. Over 7 or 8 years of duration, there is only one accident which happened here in actually very close to Google's headquarters. And that was because there's a big bus which is turning to the right, and somehow the camera did not work, and backup camera did not work. They could not, the system could not find it. And that was considered to be a software failure. It was a Google problem. Google paid for it, but nobody died or anything like that. It kind of went and hit that bus. Bus had a little damage, let's say $10,000 or something like that. And that's it. That's where it stopped. Fortunately, there's no life lost in that. But that gave a wake-up call to people who are designing these things, that how to address some of these real-life issues. And if you search around on the internet a lot, then you will find there are questions that suppose this automated car suddenly finds two persons. On one side, there is an old man trying to cross the street. On the other side, there is a lady with a little kid in the pram. Who should it save? Because it's going to hit somebody, one of them too. And those kind of decisions, like in real life, it doesn't happen. I mean, I've been driving for so long and I never get that situation. But when you're writing a software, when you're doing this artificial intelligence, you need to take care of some real corner cases which will impact the legality and challenge the very existence of that. I mean, otherwise, the whole innovation dies, because if it doesn't help human being well, you have to just think of something else. Anyway, I move to this next slide. So you can search the automated car. You might have already read about it. One can talk for hours and hours on the automated cars. The good part is we already have in our lives, at least in American lives and in European countries, some areas, already there are lots of cars which have lots of these features, which almost works like an automated car, though there has been no legal, or let's say no government clearance except for in California. California allowed Google to drive these cars without steering. Okay, and Google will be responsible. They took the undertaking, so they have been allowed here. But outside California, I don't know. There are 2 or 3 places where some experiments are being done by Uber and other companies who do car sharing. So those places have allowed in a restricted zone of few hundred miles or something like that. But rest of the world is not seeing a car without a steering and without a man driving in control yet. And the general gut feel is it will take several years, 10 years, 20 years more before things become ubiquitous all over the place. Okay, this one is a very quick intro of another innovation. And I was part of this innovation actually. It's called Solly. Google came up with that. Rahul Raj, you're raising hand and I'm not looking at it. If you have a question, remember to see the email and send it to me later. Or at the end, I'll have a little Q&A and you can ask that. I'll open up your mics. Okay. Okay. So this is a device. Go ahead. Hello.
Hello.
Yeah, I mean, right now, keep yourself mute unless you're not able to hear me. Okay, good. So what is happening here is it's a watch that you see. You guys must have seen a watch which is paired with a phone and you can see the directions or whatever you want. So here there's a map and the person is actually moving, it's doing a chutki, right? Just with the thumb and forefinger, it's able to control the zoom and pan of the map of the watch. And how it works is basically radar technology that's deployed. There are 2 or 3 technologies that's working. They've been working on this. Similarly, here it's controlling the alarm or time or something by just. So you're not even touching the screen. You are only from outside. You are giving some direction. This is a lot of future. This kind of innovation has a lot of application in future, in terms of doing a presentation on the screen or doing anything. The way it works is it is a radar which sends signals and then it maps up what happened. Was it a click or was it a clap or was it a hand up or hand down and so on? All right.
First of all, what is...
Let me pause this a little bit. This is another video I'm going to show you of a great innovation. And I'll talk about this a little bit later. Let's listen to this and then I'll talk about it. It deals with the transportation again. Oh, sorry. There we go. Here. Play.
First of all, what is it? Well, in broad terms, it's a 5th mode of transport. So far, throughout history, we've been using trains, cars, planes, boats, and technically rockets, but I haven't been in one, and you probably haven't either, so that doesn't really count. The Hyperloop is going to be the 5th form of transport. So going into more specific details, the Hyperloop is a high-speed transport system in which passengers sit in a pressurized capsule that rides on a cushion of air. The capsule operates in a sealed, near-vacuum environment. The propulsion system is still to be chosen from a number of options, 2 of which are magnetic levitation or air pressure, similar to that of an air hockey table.
It's just a low-pressure tube with a pod in it that runs on air bearings, on air skis, with an air compressor on the front that's taking the high-pressure air buildup on the nose and pumping it through the air skis. It's really, I swear, it's not that hard.
The system is proposed to travel at an average speed of 900 kilometers an hour and at a top speed of 1,220 kilometers an hour. Elon really doesn't have...
Did you hear the speed? 900 kilometers per hour. And it can go as much as 1,200 or something. This project was actually, this person whose video you see here, the picture you see on the screen, is the person behind something called PayPal, which is what you guys do with something called Paytm, similar company here. And then later on, he used that money to fund into something called SpaceX, which is a dream for him to go to Mars and set up a colony in Mars. But while doing all this, he had a problem. He actually lives in Hollywood, probably because his wife is there and so on. But his companies are here in Silicon Valley where I live. So this is distance of about 400 miles. which is 640 kilometers. And this distance he had to cover sometimes twice a day, or at least once a day. In the morning, he would come here and then go back in the evening and attend other things. So he's supposed to be in the middle of that problem, that how do I commute fast? And of course, you would expect if he's this rich, he has his own hangar on the Los Angeles airport and he has his own planes. But even with planes and all, the speed was bad. And when you heard that speed of 900 to 1,000 kilometers per hour, that's faster than a plane that flies, almost in a similar ballpark, but faster. But there's a difference. What happens is when you go to check in the plane and you try to fly on that, you have a whole 2-3 hours of time before and after. So the time to travel from Los Angeles to San Francisco is roughly in the tune of about 4.5 hours by plane, end to end, from home to office or office to home, whatever you take it, one way. Whereas if you take a car, the same distance with the traffic and all that, to cost us about 6 to 7 hours. I mean, sometimes I drive crazy fast, but what is crazy fast for me is like 100 miles an hour at the most. You would probably make it in 6 hours. That's the best. What he proposes here is called Hyperloop, which is the same distance it will cover and do the distance in 35 minutes. Okay. And there is so many benefits he suggested. It was not just one innovation. It sounds very obvious that what you're doing is you're taking a big tube, make a vacuum inside and put a little module. Inside the module, there are 4 or 8 people sitting. And then suddenly you suck the air out. So there's no friction that it faces. Airplane faces friction. Train faces friction from the railways, tracks. Car is all the time getting frictions and all kind of stoppages. This design that he's talking about, this person is actually a fluid mechanics engineer from a very reputed college on the East Coast, University of Pennsylvania. But that's not the thing. He took that thing, he took his own team of people, and overnight he designed this concept. But he said, I'm not going to build it because I'm busy going to Mars. So he gave this project to several companies, and one of the companies took a lead, and that's the PowerPoint that you're seeing, that's the video that you're seeing. One good news, because most of the people are scared of doing something new, putting money on something big and something new. There is a project in India, it's probably Bombay to Pune or somewhere in Pune it is being built, this Hyperloop, which will cover the distance much faster, cutting edge technology, and it's possible that the India solution will come up faster than other solutions. In US, it is being prototyped in a place called Las Vegas. They have been doing prototyping for quite some time. The same company, Hyper Transport company. But yeah, it's extremely exciting innovation.
First of all, what is it? Of an air hockey table.
It's just a low pressure tube with a pod in it that runs on air bearings, on air skis, with an air compressor on the front that's taking the high pressure air buildup on the nose and pumping it through the air skis. It's really, I swear, it's not that hard.
The system is proposed to travel at an average speed of 900 kilometers an hour and at a top speed of 1,220 kilometers an hour. Elon really doesn't have that much time to do this one. He's too busy building rockets, electric cars, and batteries to power homes. So he's given away this idea and outsourced it in the form of a competition. Several companies have formed to take on the project, and even some all-star interdisciplinary student-led teams are working together to advance the Hyperloop technology.
I mean, it's clear that the public and the world wants something new. And I think you guys are going to bring it to them. So congratulations.
Elon states in another interview that this initial concept came to him when he was stuck in LA traffic, which caused him to be 1 hour late for a meeting. So that's all well and good, but let's weigh out some advantages and possible problems with the system. First, the advantages. Theoretically, the pods can't crash. It's also much cheaper to build. It's about 1/10 the cost of the proposed California high-speed railway system. This means that tickets could cost as little as $25. It's also a lot faster. You can basically get from downtown LA to downtown San Francisco in 30 minutes, and it would take about the same time to get from Amsterdam to Paris. Just as a side note, for distances longer than that, it's actually more economically viable to use a supersonic jet. It's also extremely energy efficient due to solar power utilization. In fact, the Hyperloop could generate more power than it consumes as a closed system. Alright, so back to the present day. Let's look at some current progress of the Hyperloop. So right now, tracks are being built in Nevada, allowing engineers to test systems and refine their designs. 3 companies have already begun funding rounds to operate the Hyperloop. They are Hyperloop Transportation Technologies Inc., SpaceX, and Hyperloop Technologies. Hyperloop Technologies and Hyperloop Transportation Technologies Inc. have been talking to 10 governments, including China, to build Hyperloops in their major cities.
Sorry, the video is slightly dated. It did not talk about India, but I have that information that's being done in Pune somewhere. So that's a good thing to hear. It's always good to hear about your country than China. Okay. All right. So I mean, just to understand, that thing fascinates me. Why it fascinates is because it says it will not take energy from anywhere. There's plenty of sun in California or so many places on the planet. It runs from solar cells. It will actually generate more energy to give it out to the local villages. It'll go frictionless. The project is costing 1/10 of a proposed bullet train that they're trying to build for last several years, and it's not working out. And overall, the body will not get that much tired because you're only driving for 35 minutes, right? And what they have done is they have also come up with concepts of making it so virtual that when you sit inside, it will not feel like you're going anywhere. It will feel like you're stationary. You got in that box, watched some movie for 35 minutes and came out, and you are in San Francisco now. Or similarly in between Bombay and Pune or wherever they build it. So it's really, really very interesting that how people can come up with newer ideas, whereas we've been doing trains and things like that for 200 years at least, right? So that's the point. And now, if you look back, in fact, I in one of my presentation I had said that the way cars were designed in the past were totally wrong. We didn't know because we kill people with those cars. We drive on the road. We have people who are absolutely ruthless drivers, fast drivers, and they don't care. On the other hand, we're sharing road with another person who is 75-year-old lady who has no clue what to do with the speed, and they crash, and both of them die. Right? This thing actually cuts down those deaths. It's that much game-changing concept, right? All right. So how to make things happen? Yeah. So do not get consumed in daily life so much that you cannot have a little bit time left for creativity. I mean, I normally joke about that 20 years between the age of 30 and 50, we are totally consumed about so many other things. We don't even know where it vanished. I did not know when this 20 years vanished for me. Okay, and that happens to many people. That after a while, you suddenly realize what the heck happened, and it looks awkward that primarily you are doing only for family, things for family, but you were into a job, you were all the time doing things which totally consumed you from doing anything creative. So that's my suggestion, that you will have to go through that, but try to keep some time aside where you can do something more interesting, something challenging, something that can make the world change the world in some manner, a little bit here and there, whatever. If you can do this big, like make a I mean, these things are huge. They take a lot of time and money, but whatever best you can do, anything new you can do, that will make you feel good. Okay. And it'll actually be good for everybody else as well. Okay. So as an engineer, that's the privilege you have. You guys are engineers now. I mean, you're going to become an engineer, and you would have a chance to do that. So keep that curiosity alive. Problem solving, problem cases. When I look at a problem, even now, in fact, I was talking to one of my, not classmates, actually he was junior in IIT Kanpur. And he said, the moment there's a problem, I get excited. So there can be a problem which makes people get scared. And he says, no, I get excited. Now I get to do something. Life is so boring otherwise. So yeah, take the problem bull by horn and do something new, do something cheaper, cooler, better. Okay. All right. So from here, I switched to add slides which are a little bit about AI. AI is a very sophisticated technology, way ahead of rest of the computer science and computer networking and so on. It uses almost every department of computers that you would probably study or you have studied. So it is not something that I can cover in 15 minutes out here, right? On the time front, we have already done something little less than 1 hour because I started late, sorry. But let me touch base on AI. Some things you might already know, but my perspective, okay? My perspective in the sense that, what happened to this slideshow? I hope I can do still. Current slide, good. All right, so my first statement here is, and by the way, these are all coming not from internet, purely coming from my own brain. So somebody can challenge it, and I tried to send this PowerPoint to quite a few of my friends and well-wishers around. And thanks everyone, whoever went through this and gave me some feedback. So I see that humans are the only animals who can understand how the brain works, how the intelligence works, what is involved in it. And that's partly the reason why we can do and we can change things that were not really meant for that. I mean, good, bad, whatever you say. For example, you say, we'll make a robot and he can start fighting a war and he will kill the human, right? He can totally kill all human. So there's a danger involved in that. Or there are lots of such stories which are bad things that can happen. But in all situations, human still leads because he's the one who created. He'll be able to find a way to what we call is a workaround or try to disable when things go wrong, right? So that is the beauty, that we know how the intelligence works. So now can I pass on that intelligence to my next generation of things called robots and AI? Then they have applied their intelligence to build computer systems and programs. So all this while, let's say until, I cannot say that because in fact in my IT course, 35 or 30 years ago, I did do a course on AI, right? So given that AI was being taught even at that time, natural language processing was taught at that time, but it did not make a whole lot of progress. But what happened is we had programs, and programs have something, any of you who have done computer science, a little bit of programming here and there, you know there is a if then else, like if this happens, then do this, if no, then else, then do something else. We are kind of limited by those kind of constructs. We're only thinking of a logic, a binary logic, either it's red, or, either it's day or night, or is it something you define, and so it's all preconceived. The moment something new showed up, the program could not handle that more, okay, because it had a very limited, you call it finite state machine, which is it's a finite set of things that can happen to it. But that is the barrier, that because human don't have that limit. If human had that limitations, those kind of limitations, then we have never made more progress. We would have probably stayed like we were millions of years ago, right? Whenever we came, we would have just stayed where we were. But human kept on learning, and that is where the whole thing changed. So people came up with a concept where they can make the programs learn from the data they have. What happened to that small child I was talking about? When he's born and for 6 months, he has no idea who's mom, who's dad, who's this person, or what is an object, no idea. But kept on learning, right? So that's the kind of thing that you pass on. And that's like first half of the job that AI does, that you make the system learn a thing. Actually, I think I made a mistake. Some of you should have pointed out. The second word is not interpretation, it is inferencing. Inferencing systems. So let me correct that while we talk to you. And that goes to, I'm sorry. That goes to a point that somebody on the chat asked me, how many hours do I work? That's a very, I hope my boss is not there on the call somewhere. But I choose my hours. I do all kind of things around. And I don't take the work as a job or something. So in a way, except for the dreaming time of sleeping, I'm always working something, right? It doesn't have to be a job that pays me money. It can be anything that is interesting that's going on around. Okay, so slideshow from current slide, yeah. So coming back to this, I say actually to answer that question, yeah, if I'm awake, I'm working. I'm doing something. It's impossible not to do something when you're awake. Okay. Okay, they're working. Yeah, go ahead and shoot that question. I'll try to answer that later. So I do work at times. Let's say in a year, there are pockets of times when I have to work really work as in job work, close to 12 to 15 to sometimes the whole 24 hours. I'm not a doctor that I have to be on call all the time, but that's the way I operate. That when there's a need, there's a business need or there's a technical need, and we are not able to solve problem, we it's not just me. The whole team that we have around, they are all very dedicated and we work very hard. But the moment that goes away, then I sleep. And even in the days like right now, when I'm in that mode where I have too many things going on, that's one of the reasons that this presentation is not very well made or not very well organized. I mean, it should not have gone the way it has gone so far. But content is there, so you can probably understand that. So these days I'm working in the tune of about 14 to 15 hours a day roughly, which is quite a lot. But even within that time, I'm able to find an hour to play tennis. I play tennis more or less every day. So it's the way you cast your situation, how you want to do a thing, what is important for you, what are your priorities. I take care of my family as well. Um, so 5 days you're working, 2 days are off here. In US, you have Saturday and Sunday always off. And Saturday, Sunday, we do work a little bit, but mostly we do home things. So we take care of home stuff. We take care of, we sleep. I sleep a lot on Saturdays and Sundays. So it's like that. But a time would come when I have less load, less things going on because there's a project going on which takes time. Then I'm doing something else. Just having fun, going out places, whatever, meeting people. Like anybody, I like to meet people all the time. Minus this COVID-19 situation. So I had my own ways of working around COVID-19 also. I used to play table tennis in my home only by putting half of the table tennis up and keep hitting to myself. We have fun, right? So there are always ways to figure it out what to do and how to enjoy your life. And I again, you can innovate there as well, what to do. All right, so coming back to this learning system, the AI pretty much, I mean, it's kind of making it look very simple, but pretty much works in two separate systems. One part of it learns, the second part uses the data out of the learning and then draws inferences. So one of my friends here actually suggested that it's not just a model, learning model. I used a word here, acronym here called CNN. You might have heard this, convolutional neural network. So you create, just take it as an object, you create something out of a data by creating learning systems. And once you have that data, then you go to another system which will take this and draw inferences based upon the data. And for example, if you have to design a automatic driving car and it has to go and on the road and see whether it's a bus or it's a person crossing or it's a bicycle which is coming in, they are all very different objects. They are not similar pictures, and the computer vision would actually take those data and try to see. One way is that you brute force, you compare all pictures, but you cannot have all. Every single bicycle looks different. Every man looks different, right? So what they do is they make a learning system where, like that little child I talked about, that it will keep on seeing and say, if that thing looks like a two eyes and two legs and so on, then it must be a person. And if it looks like a tall thing over there, it must be an electric pole or it's a tree or something like that. So all that is not being done by just looking at the picture. It's also by making the system itself learn from lots of data that on the road, you are going to see these things. Okay, now you differentiate between that based upon a thing called neural network. And this is a huge topic by itself. I actually fascinate this topic quite a lot because in terms of plain mathematics, it's a very linear thing. It's just a y equal to mx plus c kind of a thing. But it has to do over billions of data at a time simultaneously. And that's where the powerful computers and powerful processors come into picture. Similarly, once that model is there, then you feed that model and now a new picture comes, then you try to fit in here and say, okay, that means it must be a man or it must be a tree or whatever. And that word is called classification. Now, what really happened is in the cured data, you gave him 100 or 1,000 or millions of pictures and you label that this picture man, this picture tree, this picture is an object, a rock, and so on. And based upon that, your learning system developed. In the interpretation, you gave a new picture and said, go figure it out what it is. Now, it will still not, if you match dot to dot, it will not match any of those things that you had given here. But this learning system will make it derive that most likely 80%, 90% chances that it is a man. And so apply the brake, otherwise the guy will die. Or it's a rock, and apply the brake, otherwise you will die, right? So this combination of a learning system and inferencing system together, they create the big picture of AI. Because what happened just now? Now you're not saying, look this picture and it matches, then if this, then that. It's not, you're not saying that. You're saying that I gave you millions of data, you learn how to decipher, and you learn to the point that now you know who is your mom, who is your dad, and who is this stranger, and who is the policeman, and so on. So that's what happens to this system. They keep on learning and growing. Their brain keeps on growing. And then eventually when the car is on the road and that models are present inside the car, it will clearly identify what is come in front of him and what next action to take. Okay. I know there could be lots of questions on this itself. It's a vast topic. I'm kind of trivializing it. Okay, some subfields of AI, and you must have heard few of them. Machine learning is, I don't know exactly why it became red and I did not pay attention to convertible, but machine learning is a very interesting and very, very challenging thing. A lot of activities happening in this area. And what is it about? It's basically making the first block that you saw there, learn, right? And how effectively, how fast you do, how you structure your learning is basically saying some children learn a lot and some children don't. It's like that. So some of the models that are being created, lots of models are being created and thrown and created again and thrown. So it's more like an iterative process where you come up with new things and finally can say, okay, this one is working very well. So machine learning is there. Then there's a deep learning, which is very useful for applications where you go search into the data and come up back and say, okay, most likely this is what is correct. And one example is, for example, music or a movie. So everybody has his own flavor and taste of movie and music. So you cannot say that if your dad likes Muhammad Rafi songs, so you'll also like Muhammad. You cannot say that. So everybody has that pattern, that he has a set of pattern he likes, God knows what, Dalar Mehndi or whoever. But it just doesn't stop at names. What it will do is it'll find a pattern, what he has been listening in the past, what he has been liking, and based upon that, he'll say, here's a new one. Surprising, I'm surprising you. I gave you a new song and I'm 80 to 90% sure you're going to like it. Okay. That's the typical job that deep learning does. Okay. That it'll come back and predict, like the classification that you saw there, inferencing system, it'll eventually tell you that chances are very high that you will like it. And in doing so, they are always modifying the model to make it from 50% to 60% to 70%, as close to 100 you can do. But mind it, it's never 100%. It's just a prediction. Okay, but the predictions are getting better and better and better, right? Cognitive computing, like to understand what is happening, what the events are happening, all those aspects that you see, that is handled in the cognitive computing. I'm going a little fast. Computer vision, we already talked about that. You improve your vision based upon the learning. Natural language processing is where you take a language, English, Hindi, whatever, and then try to understand what is being said. You also try to understand the nuances, the semantics of the language. All of it is being, and all of these are extremely challenging projects. I mean, you can imagine that big corporations like Facebook and Google and all, they're spending tons of dollars just to develop that. Thousands of people are working on it every day, come up with new ways of doing it, new models to propose and then execute that, make it happen. And all of this at every step, every day, there is some innovation going on there. Conversational AI. Now, conversational AI is typically what I showed you about Alexa or Siri. You have heard of Siri, which is in iPhone and iOS, and or Hey Google that you do. I think there's a Cortana by Microsoft. These four are very strong in the, but I think among these, most of you will agree that Amazon has a good lead. Amazon and Google have the most lead in the market. Well, I can't say that because Siri was probably one of the early ones which started recognizing very well. Okay, so these are the fields of subfields of AI, or you can say, And all of these are all very tightly related because they're all doing the same learning and then followed by inferencing. Technologies which enable and support AI. So, of course, there have been too many enhancements that have happened in computer field. And GPUs, graphics. So you heard of CPUs. Now we have graphics processing unit. Basically, a lot of parallel computing that happens inside these little tiny devices. They actually get very hot also because they process a lot. They are still processing the same linear functions that they're performing on the data, but they're doing far more efficiently. And there is so much hunger in this game because you're talking about processing billions and billions of things which are available on the internet. So as a result, it looks almost endless how it will pan out, how much can you really keep making your GPUs faster. You have to make it bigger, you will have to make more current flow inside that and so on. Internet of Things. Internet of Things is basically where you generate lots of raw data. Sensors, like you look at the temperature of the thing and you generate data. You, in a medical system, you are generating all kind of readings like ECG or EKG, whatever you perform, and that generates data. And there's so many data, even one person generates so much of data, right? So IoT helps providing the data, which is, you can call it uncured, and then somebody will sit down and put a label on that saying, okay, this data is this person's heart rate or whatever it is. Advanced algorithms. So algorithms still keep on developing. And the point here is that with the help of the AI model of learning and inferencing, you still try to draw very sophisticated conclusions out of that data. And you definitely use the probability. If it is 80% correct or 60% correct, based upon that, you will apply. But algorithms developments still continue happening. Models development have to happen. And last one is APIs. Basically, it is a way to connect already existing so many banking applications, so many email and applications, and so much of things that you see in Microsoft Office. You still need to connect that to the AI systems. So, for example, if you used the Outlook email system from Microsoft 10 years ago, it had no artificial intelligence. Okay. It still is a thing of joke, but they have now started applying AI very heavily. They will actually do analytics every weekend and tell you that you had so many mails, you did not look at these mails, you did this. So it's continuously evolving, and how it evolves is they're not changing the whole software. They're actually stitching the two software together, the AI part of it to the existing legacy old part of software. And that's the AI APIs come into play. All right, next one. So some of the applications you already saw that few things that I showed you, automated cars and all those things. But today it is ubiquitous. It's everywhere. I mean, I would say at least in the United States, it's all over the place. Anything that we go to do, I mean, you do a Google and you will suddenly get surprised that, you know, it's talking about something that you had it in your mind. I mean, I'm just thinking of traveling to India. I've not talked to anybody, but I go to Google, I search for something and it says, oh, do you want to go to India? Here is a ticket. And how does this happen? Because, I mean, one example is this Alexa is sitting next to me, and I probably picked up a discussion like that when I'm saying, and it went and fed back to Amazon. And Amazon went and sold that information to a third-party company, which is specializing in giving ads. And they did a targeted ad to you. You might have heard about things from Facebook and all these actually pulled up by government saying, why are you selling your data to somebody third party, right? What happens is because that's the data they're looking for. That's the cured data. That's the data they'll cure and they'll put into the learning system. And now that particular machine knows about you. He knows what you eat. He knows what you do as a daily basis. I mean, in the past, I used to get all kind of ads. Now I only get ads which are in, let's say, sports side. The moment there's a tennis event, suddenly they'll send me an email or send me a pop-up saying, do you want to go to this event in San Jose where there's a tennis player coming and playing? Why? Because now they're tracking, they're getting all my data collected from different sources and putting in the center and processing through the AI system. So it's, to me, it feels it's all over the place. It's everywhere. Everybody is feeling, at least in the United States, okay? So we saw the autonomous cars. Autonomous cars, what's going on here is, let me just drag this little thing disturbing me. Okay, yeah, so autonomous cars uses computer vision. I just told you about, and machine learning to make fast decisions on the road, okay? And as I said before, it saves lives. Music and movie recommendations. So you play Amazon Music or you play Ghana.com, wherever you go, they're all deploying this deep learning DL, and they're giving you new recommendation, new surprise me song or new playlist, and that you kind of tend to like it. Okay, without this, if they played 10 songs, you'd like only 5 of them, right? But now you started liking, okay, now you're liking 7 or 8 of them, 9 of them. So that's the improvement courtesy AI. Automatic email or voice response. You guys use Android phones, must have seen that it starts telling you, do you want to reply okay? Or even WhatsApp, it will suddenly come back saying 2-3 options to you, okay, not okay, or I'll talk to you later. They're all effect of AI. Okay, Alexa already gave you some little demo there. Medical diagnosis would always be slower because there's a human life involved in that, right? So as a result, it takes a little longer time, but we already see some critical areas, and there are a few companies in US who specialize in this applying computers in a very sophisticated manner into medical stuff, equipment, tools, and all that. And they have started using it very effectively. So think of a time when doctors will actually be utilizing that information and then recommending a treatment. So we are headed almost there. Okay, so it's all over the place. So what somebody asked me what Alexa cannot do. Yeah, so there are limitations still. Contrary to popular belief that robots will rule the world, AI always lags behind human intelligence. So this is what I said some time back, that there will be a way to find a workaround. There will be a way to disable it, or there will be a way to divert the whole logic based upon things, and based upon the way this has been programmed, right? There is still a possibility that things can get out of hand, but at the moment, it is still limited. And one of the limitations I'll show you right now. So far, AI requires human intervention to label the data. So when you said cured data, so raw data is you take temperature of the entire population of India. 1.2 billion people's temperature is there. That's raw data, right? Somebody is sitting on the airport or somewhere and taking the temperature, does he have COVID or not? It's too much data. But now somebody is putting a label saying this temperature belongs to such and such person, this to someone. That's labeling. Okay. Now this labeling is still being done manually, and it's called supervised learning. Okay. If you see this word, and this is a catchword. This is being used very heavily in the field of AI, but it's a very boring work that is going on right now, and in a very mass scale because the volume data is so large. Okay. So far AI cannot do it. However, there's something called unsupervised learning. It's a work in progress, and there's a problem, so there is an opportunity. So one can definitely enhance that, and there are solutions that are coming in the market already. People, there's at least one guy in this audience I know who is into this stuff. AI is not being applied to generate algorithms yet. So algorithms that we write, like we write a big program which does some really sophisticated thing, that the generation of those programs have not still been handled to AI. AI is still limited to the basic things that I talked about, the deep learning and all that. It is still not gone into an area where it will start, because this is where the danger will begin. Because instead of human programming a machine, the machine starts programming a machine, right? So that's one. AI predicts or classifies up to 99.9% accuracy, not 100. I already mentioned this, that the neural networks and the learning systems, they typically give you a very high percentage rate, and anything above 90% actually sounds very good, because human mind cannot do that much. I mean, unless it's a one-to-one match. Like if you see your mom and you see her picture, you can say that is your mom. But there will be a possibility that if you see a mom's picture when she was 10-year-old, you don't recognize because you did not see that before, right? So there's a possibility that you can miss it. And same possibility exists in AI also, that it will never get to 100%. Remember, when I said if then else, it was a finite state machine, but it was 100%. It was, if you do it one time or do it millions of times, it will give you the same result every time. Not so with AI. It can have a variance because it is based upon data. As the data pattern changes, the resulting output will be different. Okay. But so accuracy also can be different, but this is not a big deal because 99.99 is pretty good, right? Like I mean, in a way, you can say that, okay, if the cars are flying on the road, all the cars are having AI. It's possible that 0.01% would land up meaning 10 guys in a 10,000 population of cars, right? So there's a possibility that quite a few people will get affected by that. Either they will be disabled or they will die. But so essentially, it is never, you can never guarantee that there will be no deaths. I gave an example of 8 million miles of car was run by Google, and exactly one accident happened, right? Which is a very good record, because you can't even imagine how many people are being killed by cars these days. In India, every year we are killing 200,000 people. 2 lakh log. Okay, in US, which is so much advanced, every year we kill 40,000 people. So if those numbers become 4,000 or 3,000, it'll be damn good, right? So definitely that's not really a drawback, but I'm just highlighting that it's not really a perfect stuff. Okay. That is all that I could put up in my current timeline, the things that I do. And actually, I should have had a slide here saying question and answer. You guys did ask some questions. I tried to answer some of the questions. I can do it later. Let me read one question bottom up. Mr. Kumar Rishav, I want to ask a question about the auto-driving cars. Are they working on Wi-Fi or a Bluetooth system, or same like sonar or radar system? Okay, so things of this nature deploy everything. Okay, for detecting an object in the front, radar is pretty effective, laser is effective, sonar is effective, and most of these guys probably have a combination of these. And even that Solly that I was talking about with the little finger snap, you can give a direction to zoom or something. Even there are multiple options that people can use, and some solutions in the market would actually utilize multiple options, because if one doesn't work, the other will work. I would guess, I haven't dived into this automated car so much to see, but I would guess they will have a backup. They'll have multiple options, because God knows in what situation, in what hill, or in what rainy situation or something, one system works and one doesn't, right? For example, radar has a very limited range. Laser has much better range. So all those characteristics apply. Lots of parameters play a role. So there's no one answer for this. The right answer is it's a combination of those things. I am assuming that your topic about Wi-Fi and Bluetooth is more for rest of the stuff. Definitely they don't use it for detecting an object in the front. Okay, the object detection is not based on that. Dr. Nirmal Kumar, what will be stand of AI in India in future in the sense of job providers and job seekers? So India is still, to answer this question, most of the software work in India that's being done, most means I cannot quantify that.
This question is from me. I am professor at BC Bhagalpur, Parimal sir.
Oh, hi. Hello. That's fine. You're hiding behind Dr. Nirmal Kumar. Okay. So AI, most of the software work in India are kind of contract work done for a European or American company. Okay, and even for that matter, Korean companies. So those work actually already are doing a lot of AI. And a lot of this labeling work is already given to where those call centers used to be, because they're all cost-saving economic situations. So a tremendous amount of work on AI is actually happening in India as we speak today. Then comes other kind of companies which will do basic innovative stuff. For example, Paytm. Paytm is not doing contract work. Paytm is doing its own software. I don't know about Paytm that they have applied AI in anything. They probably don't need to. But Gaana.com, Saban is of course not an Indian company, but it's a Hindi music company. They're all applying AI. Okay, so today, if you go to look for a job in a company, and if you are not aware about AI, it's kind of a disadvantage because the other guy knows it, right? So I would say definitely be aware of what's happening. Even if you're not in computer science, you should know what's going around, and that that always works for finding a job. So you should be able to answer questions and do on that. If you specialize in any of these things, if you do a job in an internship or something where you are able to deploy some AI technique, AI is filled up with lots of tools and techniques. Their companies, Google and NVIDIA and all, they have their own languages, programming language, their own modeling languages, own tools. And those, by the way, those tools are not something that you develop like a C and it lives for 20, 30 years. They are changing every couple of years. There's a new one that comes and beats the other one and so on. There's a very fast changing world. But if you happen to do an internship in a company who gives you a job in the, work in that area, your chances of getting hired becomes very high. Even if somebody is not doing AI, he's thinking about AI and he needs to put it into a banking job. There is so much AI requirement in that. All the banks are deploying that system now. So definitely the answer to that is anybody who is seeking job should be ready for, like sometime back we were saying, even if you're going to become a civil engineer, please study computer science topics so that you get you'll have an edge. Similarly today, whatever field you are in, know something about AI, learn something about it, get curious, find out how this Alexa works and so on. And that will give you an edge eventually, that you are better suited for a new job because you are showing that drive, learning and all those things, right? Going up, can you please explain the limitations of Alexa, if any? Yeah, so Alexa is a very limited system, by the way. There's a lot of limitations. What is it doing? It's actually why it is designed is to help Amazon sell more products. So their focus is quite a lot on trying to pick up what you want to order. And for a guy who sells things, the best part is how easily and how quickly you can order. Because if you think too much, you'll probably not order. Most of the people buy things on the spur of a moment. So that's why the Alexa's main idea was that. It was, but it made it look so cool that people started having it in their homes. And now they use it for ordering. And especially in COVID, Amazon is getting more and more popular, mainly because people want to be delivered. They don't want to go out and buy something from outside. So the Alexa plays a very important role in that thing. So it is a very focused and limited application device. But to be effective, it had to deploy all kinds of technologies. And in some way, I think the conversion, like I said, that the autonomous car was initiated by Google. Now everybody has it. I mean, they don't have the autonomous cars per se there's no car which is without steering, but the technology is there. Every company is now deploying some features of the automated car. Similarly, the conversational AI actually started with Alexa in a big way. It launched at a time when Google was not ready with their Google, Hey Google and Google Home solutions. So they have kind of multifold lead compared to other companies. And all of it goes into that name called Alexa. So that's why it works like that. Okay, what is this one? Yeah, that's all the questions I got on chat. Verbally, it is possible to take questions, but we have 50 plus people around on the call right now. Thank you everyone for joining that thing. So if anybody has a question, you can probably unmute your mic and ask. But if too many people speak, then nobody will understand what happened.
Madhuresh, thank you very much for your deliberations. You have discussed many things on artificial intelligence and innovations. You have discussed about Alexa, which is embedded with knowledge, and it will fetch the knowledge, the information from somewhere else and deliver it to the user. So this is a very important device in the present day, and I think all the equipments, gadgets in our house will be integrated with this Alexa, and it will be controlled by that, whether it is TV, whether it is car, and whether it is other appliances in the home. And now you have sensitized each and every one of us to see the future of technology, where you have to go from here. We have to travel mile away from here to get trained in the new domain of technology, whether it is related with the Hyperloop also. Hyperloop, how it will generate a frictionless path for traveling, and in a very few minutes we can travel more than 100 miles, and in 1 hour, as you discussed, that the speed of this Hyperloop will be near about 900 miles per hour. So it is all mind-boggling innovations. You have discussed about the machine learning, deep learning, and cognitive computing, computer vision. All these are the important, and the future of technology. The world is awaiting us about the most innovations of the present day, that is a driverless car developed by Tesla and Google. And it will become the reality in few coming decade. And India, I don't know whether it will be a successful venture due to bad conditions of roads and overpopulated city. So these are the challenge for India. And but one more thing about the design of the product, which you have missed, which is the application of user XP for refining the product, which is also a new domain of technology at present. So, and you have discussed, we were afraid that AI is a big challenge for the human race. But as you have discussed, so we have got some sorts of solace that AI is not able to develop a algorithm, complex algorithm. We can, the human will only develop the algorithm, complex algorithm, all about the neural network and cognitive skill power of the human. And therefore, AI will not overpower human intelligence. That is the very important issue for deriving solace by your statement. And the AI always requires human interventions to work. And your lecture is very informative. It has sensitized all our teachers, our students to make a career in all these new domain of technology. And we are ready for that. India is also ready for that, because actually India is exporting people to USA for developing, working for all these area of technology. And in this way, but in India, it is really a great challenge. So how to mitigate challenge in India? And do you have any idea about it? And if you have any idea about it, then you can say a few words on the challenge for it.
As Parish, okay, the moment you say there's a problem, there is an opportunity. The thing is how much energy we put, how much innovation we put to solve. Take the example of driving the car, right? Now, yeah, you're very right. I mean, driving car in India is a challenge itself by human. I mean, even as person to drive car, I mean, people who drive car in India are absolutely high caliber, high reflex people. Now, can that be imitated? Absolutely. If I can drive car in India, then most likely I can train a machine to how to drive in India. It's just that that is not the focus. The focus today is these American companies are developing things. In fact, the Indian guys are helping them develop those things, sitting in big companies in India, are all meant for American roads, which is extremely sophisticated infrastructure. I can keep on speaking on those things for long time. What makes really those things click? But I mean, a simplest example is that the lane driving, like there's no automation in the lane as such. The lanes are same white marked on the street, but everybody as a culture or as a because of rules and because of being fined if you don't drive like that, they are driving the lane. But biggest fear they have is if they don't drive in the lane, somebody will come and hit and they will die. Okay, so money and all can be still taken care of, but that fear of death makes them drive in the lane. Unfortunately, that fear is not there in India. India, most of the people who are driving car, they are always running for against time. They are thinking how to get ahead of the other guy. And as a result, they violate the lanes. And if the lanes are being violated like that, just imagine this car that I showed you, the tiny thing, he'll get confused. The car will sit in the middle and keep on rotating. But that doesn't mean that that's the end of the world. That means actually the start of the world where you innovate something which will make a difference. Okay. I mean, the way I would think is, if I'm given enough money, I can probably design an automated car which will be so aggressive that it will make other people also start either buying those cars or they drive like that car. Because definitely it is habitual. If you see somebody going ahead of you because he drives in a particular way, you will also do the same thing, right? And so why not do some innovation where you start doing that? Okay, even if somebody hits, nothing happens to you, and you still keep moving, and eventually you are ahead of it. This is tiny car. It's like a motorcycle, go anywhere in the middle of the corner or go from other places. Of course, today's solutions don't do it, but if somebody is behind it and you push it hard, you'll get there. And I'm, by the way, very happy with this thing that one of the most advanced project from the HTT, the Hyperloop technology company, is actually being done in India. So essentially, because that's not on the road, it's a different whole new thing, and that works, by the way, in a place where there's a problem which is unsurmountable. Then you come up with radically new, revolutionary new stuff, which is what Hyperloop is, and that becomes successful. Then you probably start looking at transport so differently that everything else falls in place. So there are things that can happen, things can change and improve, problems will be solved, but probably we'll have to take one problem at a time, solve that, and then get to the next one, and slowly. For example, before making an automated car in India, I totally like this sensor-driven traffic light, which is in the United States for the last 50 years. All traffic lights are driven by sensor. They're not driven by timer alone. They are driven by looking at a car came. If suppose there's across the street and there are no cars coming on one, that light always stays red, and this one is always green forever. The moment a car comes, it senses that car. There's a thing called electrical thing called a loop that they put inside to detect the weight of the car. Then suddenly the other side becomes red and this one becomes green. I don't know why the world doesn't do it. Now you don't need to do those loops. You can actually put cameras all over the intersection and take care of that. Solve that problem first. You solve that problem, slowly you'll get into a groove where everybody will get in the lane, and now you have an automated car that you can put in out there. So these are all problems to be taken one at a time and solve it. And you really don't need permission from big governments or anything. You can start anywhere. You can get going, whatever you're doing. And as a word called innovation is not limited to automated cars or hyperloops. You can apply that innovation in any field that you're working on, make it a little bit better. And if everybody keeps making it better, it will improve. Eventually, it will be a better place. Sorry, I keep on speaking. So did that kind of answer the question? Not exactly, Professor Nimal?
No, thank you. Now Sasank will extend vote of thanks for your deliberations.
Give me a second. So I actually put this thing here. I'm asking you to, every student to come up with some innovative idea and send me an email on that BCE MN projects. BCE comes from Bhagatpur College Engineering. MN is my Madhuresh Nagshain. And projects at gmail.com. This account I had created for this purpose only.
Hello.
Feel free to write me a mail on that. Okay. Go ahead, Shashank.
Thank you, Mr. Madhuresh Nagshain, for taking forward the understanding of all of us sitting here to greater height. I have been listening to your discourse, your deliberation, and whatever little that I could understand as a student of humanities, always seeking to understand the newer ideas that science and technology has brought about. I go by the maxim that engineering is closest thing to magic that exists on this world. After listening to artificial intelligence and the rapid stride with which science and technology has been making advance, I'm sure that this artificial intelligence is going to impact almost all aspects of our life. you talk of any one aspect or dimension of life, I'm sure that now and even in future, artificial intelligence will have direct or indirect impact on life. Recently, we passed through very troublous time with the advent of COVID. And as I was watching, in fact, the TV, I could see when people dreaded to come in close contact with some of the patients suffering from COVID, I could see that with the help of artificial intelligence, even in the hospitals, people would send, in fact, without the intervention of humans, to the wards or to the rooms where COVID patients were there, their food items, their medicines, and all that. So it was all because of the artificial intelligence. And as Einstein has very rightly, with a sense of astonishing relevance, he said that imagination is far more important than knowledge. Yes, by looking at the vast cosmos, when this artificial intelligence is going to impact our daily life, I see that imagination is playing a greater role in shaping mankind's growth. Secondly, Mr. Nagshain, what I'm a little bit worried about is that somehow that artificial intelligence is not going to impact our emotion. Somehow that emotion is the one aspect which artificial intelligence is not invested with. So I don't know in future, in fact, emotion will be invested with the artificial intelligence or not. But then, of course, we are really grateful to you for giving us a clear perspective on things. I'm grateful to Principal Dr. Nirmal Kumar for inviting you for this college, for Government Engineering College, Banka. I'm really grateful to all the faculty members and students who stood by you and gave a very patient hearing. Thank you once again, Mr. Madhuresh Nagshain, for being with us this morning. Thank you.
It is my privilege. Thank you.
Thank you very much, Madhuresh and Rajiv both. And now I am declaring this session as closed. Thank you.